here are the objectives of the lesson. After this lecture, students will be able to know about atom, atomic nucleus, and isotopes. Students will also be able to describe natural radioactivity. These are the topics that atom, atomic nucleus, isotopes, and natural radioactivity. These are the topics which are going to be dealt in this lecture. Let us start from the very basic thing, that is atom and atomic number. So what is an atom? Atom is defined as, and it is atom is considered as the smallest particle of which everything is composed of. Students, we know that everything is everything that occupies space and has some weight, has some mass is called matter, and matter is composed of molecules, and molecules are composed of atoms. An atom is the basic entity, uh, that is the basic unit for everything. Everything is made of or composed of atom. And then we'll discuss the parts of an atom. Students, as you know, there are two main parts of an atom. The one that is the nucleus, the basic part, the central part of the atom, which contains protons and neutrons, and then the revolving electrons that revolve nearly in circular orbits. And here in this figure, as you can see that there are like 8 electrons, in fact 10 electrons that are revolving around the central part, that is the nucleus, and the nucleus contains protons and neutrons in it. So next we will discuss that what are protons, what are neutrons, and what are electrons, and how we determine the atomic number and atomic mass of an atom. Okay, student, let us discuss atomic number. And what is the atomic number? The number of protons in an atom present in represents its atomic number. The number of protons in the nucleus of an atom, of an atom shows or represent its atomic number. And atomic number is represented by A. It is written as X, and in lower index it is written A. So A represents the atomic number of an atom. And what is atomic number? It is basically the number of protons in the nucleus of an atom. The number of protons in the nucleus of an atom represents or show its atomic number, and it is represented by A, and it is written as X, and in lower index we write A. And what is the atomic mass? The number of protons and neutrons in the nucleus represents its atomic mass. Students, like differentiate between atomic number and atomic mass. Atomic number is the number of protons in the nucleus, while atomic mass is the total number of protons and neutrons. The combination of protons and neutrons, the total number, the total strength of protons and neutrons in the nucleus represents its atomic mass. So atomic mass is the sum of protons and neutrons in the nucleus. And atomic mass is represented by capital Z, and it is written as X, and in upper index we write Z. So far we have learned about atomic number and atomic mass. Atomic number means the number of protons in the nucleus of an atom, and we can also define the atomic number as the number of electrons in an atom, because number of protons and number of electrons are always same for a neutral atom. We're not talking about the ions which get some, like if the atom get an electron from some other atom or material, then it will become negative ion. We call it as anion. And if atom loses an electron, it becomes positive ion. And in that case, number of protons and number of electrons are no more same for an atom. But for a neutral atom, the number of electron and number of proton are always equal to each other, and it is also called as atomic number of an atom. And atomic mass is the sum of protons and neutrons. Okay, students, next we have isotopes. And what are the isotopes? Let us define. The atoms of an element having same atomic number but different atomic mass are called isotopes. I'm repeating once again. The atoms of an element having same atomic number but different atomic mass are called isotopes. There are in fact two types of isotopes. The one that is natural isotopes, and the second one that are radioactive isotopes. Natural isotopes mean the isotopes which exist in nature, and radioactive isotopes mean radioisotopes are those isotopes which are made which do not exist naturally, but these isotopes are made in nuclear reactors. Where like in natural if we talk about natural isotopes, the example of natural isotopes are like the isotopes of hydrogen. You might have known about protium, deuterium, and tritium. Here in this figure you can see there are three atoms having same atomic number but different atomic mass. And how will you get to know that all of them have same atomic number? You have to note down the number of protons in all these atoms. As the first atom shown in this figure, that is protium, it has one proton in its nucleus, and there is no neutron in its nucleus. Its nucleus is comprised of only one proton, so its atomic number is 1, and atomic mass is defined as the total number of protons and neutrons in the nucleus. So as this protium has only one proton in its nucleus, so its atomic number is 1 as well as its atomic mass is 1. And if we talk about the second atom, that is deuterium, and it is written as H12, as you can see at the end that protium is written with H11, which shows that it has one atomic number equal to 1 and atomic mass equal to 1. Or in other words, you can say this hydrogen atom have one proton in its nucleus, and there is no neutron in its nucleus. Its atomic mass is 1 as well as its atomic number is 1. And the second one, that is the deuterium, it is represented or written as H12. 1 is its atomic number, which shows that its nucleus has only one proton in its nucleus, and 2 means there are two particles in its nucleus. And surely and obviously, if there is one proton, the other particle must be a neutron. And as you can see in the figure, that its nucleus contains two particles. The one is P, that is proton, and the other one is N, that is neutron. So um, the third atom, that is tritium, it is represented with H13, where 1 shows its atomic number means one proton in its nucleus, and 3 means there are three particles in total in its nucleus. So the atomic number of all these atoms, protium, deuterium, and tritium, the atomic number is 1, and they differ by their atomic masses. Protium has atomic mass 1, deuterium has atomic mass 2, and tritium has atomic mass 3. So all of these atoms have same atomic number but different atomic mass. That is why we call them the isotopes of hydrogen. So same like this, we can have different isotopes of carbon, different isotopes of nitrogen, and there are so many other elements which have their own isotopes, which have same atomic number but different atomic mass. If we talk about carbon, carbon has three isotopes, C612, C613, and C614. So all of these isotopes have same atomic mass, same atomic number, sorry. All of them have same atomic number equal to 6 but different atomic mass, that are 12, 13, and 14. And actually they differ in number of neutrons in their nucleus, but all of them have same number of protons because their atomic number is same. So in this way, if we talk about nitrogen, nitrogen has three isotopes, that is nitrogen 714, nitrogen 715, and nitrogen 716. All of these nitrogen have same number of protons in their nucleus, that is 7, and different number of neutrons. The first one, that is 714, has 7 neutrons, the second isotope has 8 neutrons, and then 9 neutrons. So all of such elements whose atoms have same atomic number but different atomic mass are called isotopes. Here we have taken an example of hydrogen atom that has hydrogen element that has three isotopes, protium, deuterium, and tritium. Okay, so next we will talk about natural radioactivity. What is natural radioactivity? Let us define. The spontaneous emission of radiation by unstable nuclei is called natural radioactivity. I'm repeating once again. The spontaneous emission of radiation by unstable nuclei is called natural radioactivity, and the elements which emit radiations are called radioactive elements. Students, there are so many elements in nature which emit radiations by themselves. They're not made to radiate. They are not made to emit radiation. In fact, they emit radiation by themselves, by their own. So such elements are called natural radioactive elements. And we will talk about radioisotopes, which will be the elements or the atoms which will be made to emit radiation, and those isotopes will be called radioisotopes or radioactive elements. But this is natural radioactivity by which the elements emit radiation of their own. So, types of radiations, as we have discussed that atoms or elements emit radiation spontaneously by themselves. So, these radiations can be of three types. These radiations include alpha particles, beta particles, and gamma rays. And what are alpha particles? Alpha particles are basically helium particles which has atomic number 2 and atomic mass 4. And these alpha particles are generally released by atoms with atomic number greater than 82. The elements which have atomic number greater than 82 are generally unstable, and in order to get stable, they release particle in the form of helium particles, and such particles are called alpha particles. Alpha particles, beta particles, or gamma rays, these are the three kind of radiations which radioactive element release during their decay process. And what are beta particles? Beta particles are the electrons which are emitted when a neutron breaks down into a proton and electron in the nucleus. The proton stays there, but electron is emitted from the nucleus, and that process is known as beta decay. And we will be discussing all these decays in next lectures. Okay, beta particles generally released by atoms which have disturbed ratio of protons and neutrons in the nucleus. Or you can see that the such elements which have more number of neutrons in the nucleus, and such nucleus are considered unstable, and elements release or convert a neutron into a proton and an electron, and release electron out of it. So such radiations are called, or such particles released by such elements are called beta particles. And beta particles are generally released by atoms which have disturbed ratio of protons and neutrons in the nucleus. And then we have the gamma rays. Gamma rays, actually, they are not particles, that is why we are writing them as rays, generally released by atoms in excited state. When an atom gets energized because of being in the vicinity of a nuclear process, it gains some energy and comes or it becomes excited, and in order to be stable once again, it releases energy in the form of gamma rays. So all these processes, alpha particles, beta particles, or gamma rays, all these decay will be discussed in the next lectures. And so far, students, you have to know that what is natural radioactivity, and it is the spontaneous process by which unstable nuclei release or emit radiations in order to get stable, and the elements which emit such radiations are called radioactive elements. And I'm repeating once again, there are three types of radiations emitted by radioactive elements. These radiations involve alpha particles, emission of alpha particles, emission of beta particles, and emission of gamma rays. So student, it's all for today. I hope the lecture must be very much clear to you, and you're supposed to listen it once, twice, thrice, but you have to grab the idea, and you must be prepared for the next lecture as well after attending this lecture. And I hope and I wish you very best for your studies. Stay blessed, and